Alright, chapter 5.7 is the last section of chapter 5 in our last section of the semester. So let's finish it off with a bang. Now we're working with negative exponents and making them positive, scientific notations, and we're putting all our properties together, basically. We're on the chapter review on page 422. We're going to start by looking at number 78. The instructions say, write each expression with positive exponents only, and then simplify. So we have negative 4 raised to the negative 3. So let's recall that we are not allowed to have negative exponents. Negative exponents is technically a no-no. One is not welcomed, so we don't like them. So the rule is first figure out who is being raised to the negative 3. Who is it? It's the entire negative 4, correct? So this is your base. And the negative 3 is my exponent. So if I wanted my exponent to be positive, the rule is to take the base, move it from the numerator to the denominator, and the exponent becomes positive. And then what is left up top? The invisible 1 comes out to play. Remember, if everybody goes away, 1 comes out to play. So I have 1 over negative 4 now to the third power. We can use our calculators to calculate out negative 4 to the third power. And you should end up with negative 64. So then your answer can be written as negative 1 over 64. Okay? Let's try another one. Let's look at number 81. And it says 2 over 5 raised to the negative 3. Okay? So again, we're going to figure out, well, the first thing I'm going to do, since I have a quotient and it's being raised to a power, the rule is you take each piece of your quotient and you raise it to that power. So this becomes 2 to the negative 3 divided by 5 to the negative 3. There are many ways you can work this problem, but I kind of like this way, so let's try it this way. If this way doesn't make sense, you can also try multiple other ways. Let me know and we can talk about them. So, if I have a quotient raised to a power, the rule is to take each piece of the quotient and raise it to the power. And make sure you keep the quotient. Now, we get to look and we see, well, this base is 2, and he's being raised to a negative exponent. So I must take him from the numerator to the denominator, and his exponent becomes positive. And then I look down here and I see this 5 is also being raised to a negative exponent. So the rule is to take him from the denominator to the numerator, and his exponent also becomes positive. And then we can use our calculators to simplify it to be 125 divided by 8. And you can leave your answer just like this. Alright. Let's move over down to number 87, and it says, simplify each exponential expression. Assume that variables in a denominator do not equal 0. Okay, so they gave us y to the negative 7 divided by y to the 4th raised to the 3rd. Okay. The first thing we're going to do, just like we did in 81, is rewrite this problem, okay? You want to use your properties before you start dealing with negative exponents. So let's see here. I have y to the 4th all raised to the 3rd. So when it's power to power, the rule is to keep the base, who's y, and multiply the powers. So it becomes y to the 12th. And this is y to the negative 7. Okay. Now I'm dividing like bases. And I have choices here, okay? Let me see. I'm deciding which method I would like to show you. I will show you this method. Alright, the first thing we're going to do is go ahead and make this exponent positive, just like we did before. So who is being raised to the negative 7? Just y, which means he must go from the numerator to the denominator, and his exponent becomes positive. But who else is down there? Y to the 12. He doesn't actually go anywhere, right? His exponent is positive, so he stays where he's at. And who's at the top? The invisible 1 comes out to play. So now I have 1 divided by, and think back to 5.3. When you're multiplying like bases, the rule is to keep the base and add the exponents. So I get 1 over y to the 19th power. Good. Great. Alright, let's try another. Let's look at number 88. And I have 2x to the negative 1 power, all raised to the negative 3. Well, first let's use our properties before we deal with the negative exponent. So let's use some properties. I have a product all raised to the negative 3. So everything inside this parentheses is being raised to the negative 3. But the rule is to take each piece and raise it to the negative 3. So let us do that. So I get 2 raised to the negative 3. And then we have x to the negative 1 raised to the negative 3. Each piece is going to be raised to the negative 3. Then we can clean it up, right? Well, 2 to the negative 3, I can't have a negative exponent. And since the 2 is being raised to a negative exponent, he must go from the numerator to the denominator, and his exponent becomes positive. So that takes care of him. And then I look at x to the negative 1 to the negative 3. Well, again, I have power to power. So the rule is to keep the base, which is x, and multiply the powers together. So negative 1 times negative 3 is 3. And you notice his power just automatically became positive because of the multiplication. So now I have x to the third over 2 to the third. And then, of course, let's use our calculators to finish off 2 to the third power. And becomes x to the third divided by 8. So the first thing you should do, if you are given a problem like 81, 87, or 88, the first thing you should do is use your properties to rewrite it, yes? Then deal with your negative exponents, okay? If you're given a problem like 78, where it's just one base being raised to a negative exponent, then we can go ahead and jump right to our negative exponent and make him positive, okay? Alright, now let's look at number 92. It says write each number in decimal notation without the use of exponents. So we have 1.76 times 10 to the negative 3. So this is our scientific notation that we all love. And the rule is negative 3 tells us to move the decimal 3 places to the left. Because it's negative, it means 3 places to the left. So we have, let me rewrite this, 1.76. If I move it 3 places to the left, I have 1, 2, 3. And then you fill these in with zeros, right? So this number is really 0.00176. Great. Number 94. Instructions. Write each number in the scientific notation. So this time they're giving us a number, and we must write it in scientific notation, which means we must have something like a times 10 to the nth power, right? Where n could be positive or negative. Well, the rule is first figure out where's your decimal, and then you're going to move this decimal until you have only a digit in your ones place. Okay? So let's start moving. 1, and make sure you're counting. 2, 3, 4, 5, 6, 7. So that number becomes 7.3 9, you can leave off all those zeros, right? Times 10. Now I moved it 7 places, but I need to know, is it going to be a positive 7 or a negative 7? And the rule is the given number, if the given number is bigger than 1, then this is going to be positive. If the given number was less than 1, then it would have been negative. But since 7, what was the number? 73,900,000 is bigger than 1, we write it as positive. And of course, you know you can check yourself because a positive 7 tells you to move the decimal 7 places to the right. And you would end back up with this number right here. Alright, let's try another. Number 95. Again, same instructions. Write each number in scientific notation. I have 0.0, there's 3 zeros, 0.00062. And they would like us to write this in scientific notation. Well, again, the rule is to move the decimal place until you only have a digit in your ones place. So let's do this. 1, 2, 3, 4. And stop, because all these zeros don't mean anything. I have the 6 now, so this is 6.2 times 10 to, now I need to figure out, is it a positive 4 or is it a negative 4? Because the given number was less than 1, so because this is less than 1, the 4 is actually going to be negative. So this is 6.2 times 10 to the negative 4. And you can also check your work because negative 4 says move the decimal 4 places to the left. 1, 2, 3, 4. And you will get back your original problem. Okay, this concludes the video for 5.7. Again, let me know if you have any questions.